Disclosure: this educational content has been developed using artificial intelligence.
Welcome back to the channel. Have you ever just looked up at the vast, beautiful sky on a sunny day and wondered, why is it blue? It seems like such a simple question, right? But the answer is actually a fascinating journey into the wonders of physics, light, and our very own atmosphere. It's a question kids ask all the time, and today, we're going to break it down so you can sound like a genius the next time it comes up. So, let's start with the source of all our daylight, the sun. The light coming from the sun might look white or yellowish to our eyes, but it's actually made up of all the colors of the rainbow. Think of a prism, how it splits white light into a spectrum of red, orange, yellow, green, blue, indigo, and violet. Each of these colors travels as a wave of energy, and they all have different wavelengths. Red light has a long, stretched out wavelength, while blue and violet light have much shorter, choppier wavelengths. Keep that in mind. It's the key to everything. Now, imagine that sunlight racing towards Earth. Before it can reach us on the ground, it has to travel through our planet's atmosphere. Our atmosphere isn't just empty space. It's a thick blanket of gas molecules and other tiny particles, mostly nitrogen and oxygen. This is where things get interesting. When the sunlight hits these tiny gas molecules, it gets scattered in all directions. Think of it like a pinball machine. The light ray is the ball, and the gas molecules are the bumpers, sending the ball bouncing all over the place. This scattering effect is called Rayleigh scattering, named after the scientist Lord Rayleigh who figured it all out. And here, as the crucial part, Rayleigh scattering affects shorter wavelengths of light much more strongly than longer wavelengths. Because blue and violet light have the shortest wavelengths in the visible spectrum, they get bounced around and scattered by the gas molecules way more than red, orange, and yellow light. The longer wavelengths, like red and orange, tend to travel in a more or less straight line right through the atmosphere. So, on a clear day, as you look up at any part of the sky away from the direct sun, what you're seeing is all of that scattered blue light. It's coming at your eyes from every direction, bouncing off countless air molecules, making the entire sky appear as a brilliant blue dome above us. But wait, I hear you asking, if violet light has an even shorter wavelength than blue, why isn't the sky violet? That is an excellent question. There are a couple of reasons for this. First, the sun emits less violet light than it does blue light. And second, our eyes are simply more sensitive to blue light. Our eyes have 3 types of color cone cells, and the ones that detect blue are stimulated much more effectively by the sky's light than the ones that detect violet. So, our brain mixes it all together, and we perceive a beautiful, vibrant blue. This same principle also explains why sunsets and sunrises are so fiery and red. When the sun is low on the horizon, its light has to travel through much more of the atmosphere to reach your eyes. By the time the light gets to you, most of the short wavelength blue and violet light has been scattered away from your line of sight. What's left over? You guessed it. The longer wavelengths of red, orange, and yellow. These colors make it straight to your eyes, creating those spectacular, painting-like skies we all love to watch. So, the next time you're enjoying a beautiful day, you'll know that the blue sky above is a giant, beautiful physics demonstration. It's the result of sunlight, a blanket of air, and the way different colors of light interact with it. It's not just blue. It's a story of waves, particles, and perception. Thanks so much for hanging out and getting curious with me today. If you enjoyed this little dive into the science of our world, do me a huge favor and hit that like button. And be sure to subscribe so you don't miss our next adventure. Got any other big questions you want answered? Drop them in the comments below. Until next time, stay curious.